our chart for this was the gold chart. And again, lots of formulas with these circles. And so it depends if you're finding like a segment or an angle inside those triangle or inside the circles. So our first one here, so again, this would be one that right now I could understand that you'd be like, I don't remember doing this at all. So what we did with this kind is this is where two chords are intersecting inside a circle. So I take these little parts and I'm going to multiply them together. So I'm going to multiply 5 times x. And then I'm going to set that equal to the other half multiplied. So 4 times 10. So the little segments get multiplied together and then set them equal. They become proportional. So then I divide and I find out that x would be 8. But again, if you're not in this chapter, if you've never learned this, that probably is like, wow, that seems made up. It's kind of bizarre. But that's just the way those types of problems work. All right, these next two are asking about angles and also arc measures. So, so in terms, and actually I think this spaceship or something. We have, we're looking for 2 angles and an arc, but this one actually is from our test that we did with this. So there's what we call an inscribed angle here. So inscribed is centered at the center of the circle. So what do I know about x compared to 54? It's going to be the same. So x is 54. Now our y, or sorry, that should be a central angle. Y is what we call a central or inscribed angle, and because it's on the circle, what's y compared to 54? It's going to be half. And sometimes using a little bit of logic, kind of like this, like saying like, well, it's obviously smaller than x, it can't be double. So it'd be 27 degrees. And then they want us to find the measure of EF, that arc EF, which is on the edge. So EF would be over here. Now they give us these 2 little marks here that tell us that those are the same. So I call this like M. This would also be M over here. And then they give me this little 54. I know that all the angles or all the arcs in a circle should add up to 360. So I can do M plus 54 equals 360. So I can move that 54 over. And divide by 2. So we find out the measure of that arc there, EF. So that'd be, EF would be 153 degrees. Our next drawing here has an angle outside the circle. And since this is outside the circle, this angle has a relationship with the 2 arcs that it kind of cuts into. So this arc and then also like this little one here. Now the little orange one, I don't know what it is right now, but I can find it because I know all the way around I know all the way around this way is 184. This is 120. So the little orange part is basically what's ever left over if I take that away from 360. So I'm going to do 360. 184, and I find out FG is 56. that's this little arc here. Now what our rule tells us to do is that this angle on the outside is half of those two arcs subtracted. So x is half of the big arc minus the little arc. And again, once you start seeing all these different formulas, you're probably like, oh yeah, that's right, there was a lot of formulas. And again, we got to use a chart. It's just that chart's got to kind of get transferred over to your note card. So the big arc would be 120, because that's the angles intersecting with that arc, minus this 56. So we're doing 1/2 of 120 minus 56. So that's 64. Yep. And then half of that would make that angle 32. So that's this angle up here. So again, I would take the whole chart that we made from chapter 10 and put it all on my note card with drawings, with as much information as I can give. Our next one here is talking about the equation of a circle and graphing that circle based off of that equation. So hopefully we do x minus h squared plus y minus k squared equals r squared. That's our formula. Now remember, in the formula it has that minus h minus k. What that means is the center is always the opposite sign. So whatever the center looks like, we're going to take the opposite sign of that. So it looks like a positive one. That means our center is actually -1. It looks like a -5. That means it's actually +5. So that's the center of our circle. So I'm going to put a dot there. There's the center of my circle. And then our radius is r squared is 9. So then I take the square root of that, and I know that the square root of 9 is 3. So that's our radius. So I'm going to go every direction 3 units. Up, down, left, and right, 3. And again, with all of these, it's not like there's going to be a bunch of graphing circle problems, but you'll have to do it at least one time, and you don't want to not be able to do it just because you didn't write it down. All right, our last one here is our, this is a tangent line outside the circle. So it's this little line here, and there's a formula that we say the tangent squared, and we're not talking about SOHCAHTOA. We're talking about a tangent line which intersects the circle at just one spot. Is going to equal the outside part times the whole other line. So the tangent is just this little x squared here. The outside part is the 9. The whole line is this whole thing. So that'll be 9 plus 7 all the way across, so that'll be 16. So I'm going to multiply 9 and 16, I get 144. And so then when I take the square root of that, I find out that x is just going to be 12. So again, a lot of this probably, even as a teacher, I'm like, wow, I forgot we did all that. That seems like a really long time ago. And just being aware that that's something that is going to require probably a little bit of note taking, a little bit more of like reviewing. So we're doing up to number 26. So again, again, we're continuing on what we've already been doing. And again, you're just finishing 22 through 26. Now these do have multiple parts, so don't underestimate them. They will take a little bit more time.